In the first part of lesson 6.2, you were given a function and you had to find the inverse. In this part, you're going to be given two functions and you're going to have to figure out if they are inverses of each other. So the way you do that, you find f compose g of x. So you find the composition function, and if that equals x, then the two functions are inverses of each other. And this word we should change to or. So you only have to do one of these. Either do f compose g or g compose f, and if you get x as your answer, then the two functions are inverses of each other. Alright, let's start with number 11. So I have my options of f compose g or g compose f. I'll do f compose g for this problem. So f compose g is when you take the g function and you plug it in for x. So I have 8 times 1/8 x plus 12 minus 12. Distributing, we get x plus 8 times 12 is 96 minus 12. So you get x plus 84. We did not get a final answer of x, so we say no. F and g are not inverses in this case. So now I'm going to move on to number 13. So let's try g compose f this time. Doesn't matter which one you do. So for g compose f, we take the f function and we plug it into x for the g function. 1/4 times 4x minus 1/2 plus 1/8. Distributing, we get 1/4 times 4 is 1, so 1x. 1/4 times negative 1/2 is negative 1/8 plus 1/8. These cancel out, so you're left with x. So since our final answer is x, we say yes, they are inverses of each other. So again, you have the choice of f compose g or g compose f. I'm going to try f compose g on this one. So you could look at it and figure out, would you rather plug in f into g, or would you rather plug in g into f? And remember that it's backwards, so f compose g involves g getting plugged in to the f, the equation. So in this case we have 4 times 1/2 x minus 3/2 plus 1/2. Distribute and simplify. 1/2 of 4 is 2. 2x minus 4 times 3/2 is 6. So 2x minus 6 plus 1/2. Well, we can already tell that doesn't equal x, so I can already write no. Alright, and the last thing we're going to do in this lesson is we're going to take a function, and based on its graph, we're going to figure out if the inverse of this function is also a function. So first thing I need to do is graph the equation given. So this graph has a slope of 2. Remember, y equals mx plus b form. Slope of 2, and the y-intercept is negative 3/5. And so to figure out if the inverse is a function, your graph doesn't have to be perfect. So I'm going to go to -3/5, which is here, and from there I'm going to go up 2 and over 1. Points, you can draw your line and try your best to go through all the points. Alright, so we learned a while ago that if you do the vertical line test, you can figure out whether something is a function or not. If you want to know if the inverse of this graph is a function, you do the horizontal line test. So if I draw a horizontal line, it will never hit twice. So no matter where I draw the horizontal line, it will never hit twice. So we know that the inverse of this function is a function. So we say yes. The reason is it passes the horizontal line test. So again, you do the vertical line test if you want to know if something is a function. You do the horizontal line test if you're wondering if the inverse of that graph is a function. And it passed the horizontal line test, so the inverse of this graph is a function. Alright, go ahead and try the even problems, which includes one word problem.